rebound, slow bump, and a slow rebound. So that we have a backers and spring rate. Spring rate is what is the power, how much the force there are, and usually measured by pounds per inch. Just like in the metric unit, it having just a newton per meters, and that will be meaning or the newton in the millimeters. Will be this is the something. A spring rate. The more you get into the spring to force, the more the car push it and keep it, and the less you have it. So that will be meaning if you have a straight line and very smooth surface, I will be always keeping a good edge to make it very stiff to the spring rate. That will be me keeping the car. But if you have the car, but you have to need a lot to corners, a very slow corners. You need also very good control these low corners. Alongside with there is a lot of pumpiness to keep it, just making sure that the car doesn't too much lose the wheel spin of it. If it is too stiff, then you need a little bit getting it less stiff weight and just a spring rate. But it's just making it also meaning even the less you have a spring rate in the fast corners, especially the less you have also the creep on the corner. So it's also control meaning. So usually faster the races, the faster the rack, and less it have a bumps and curves. Remember, the curves is the most important. There are always different curves, and some curves, if they are very heavy elevation present, that will be meaning that there is a slow rebound. Once again, we have a 10 per second. This time it's how much of force per to measure it distance and per second. A slow rebound, how much it is put it back to the keeping after the per second route, how much force. So we have a slow bumps all around the cars and a different side. If we want a right side and left side, we usually put a depending on track a lot. This is the one of the settings that is measured of the track by track when you want to just a difference. So if you have a lot of left side corners, you want a more bump over to the right side, because in the left you need a little bit looser control. And to contrast, if there is more right corners than left, then you just have the left more stiffer steering. Alright, that was a pretty simple principle of then. A fast bump or fast rebound. Yes, there is fast bump also. The fast bump meaning the difference in the slow and fast bump is that the fast bump is immediately the work. If the slow bump is it just as it is fastest slowness here. So that doesn't mean it usually fast bump have a less force than slow bump, because the fast bump is just making sure that the spring are really keeping a third spring. And then there is of course remote damping. There is a fast rebound and slow rebound in both sides. And this rebound of course is once again is the same in the spring and wishbones. So we have a theory of wishbones, fast rebound and slow rebound, as we have a third spring on this. It's extension and different rebound. So we have a theory also above where we can set up. And it differs a lot once again on track you are driving, what side you be, and symmetrical as slow action. And then there is a bump damping. The fast bump, a slow bump, also making a difference here is asymmetrical. And it depends on what side of car you really are making. The fast bumping is a very important. Once again, understand for the car, the curves are a slow track. We need a loosened wheels and a less stiffer to the control mechanism. So it's a pretty simple. These are 4 different things, and then it's of course the main thing of is a right height and springs. So we have a spring rate. This is the main element. How the wishbones as it's a suspension to push the car to, and in this kind of we are street circuit, we are making sure that we have a less spring rate. So we want to just mean that the car can adjust to the cornering. Our right height. Usually we into this slow corners. If there is a wet condition or some dirt, and if there's some jumps, we always get higher the car right height. If it's a very smooth track, if it's very straight track, then we of course want to also the track to the less more lower the car is, the less it also have a ride height, also meaning that it will be develop a downforce, a crown effect when you have very close the car, because there is a Bernoulli effect. The Bernoulli effect is if your car is just sucking very close to different material at very high speed, it's taking already the Bernoulli effect. It's just getting the crown effect developed, because the air where it's just very fast, there is very small amount of air inside, and to the flow over these two different surfaces of the track surface and the bottom of the car, and that means the Bernoulli is making the suck towards it each other. Both elements make it suck. This Bernoulli effect is very important to get in more. So that's why it's very important usually have a small ride height when you need a lot of downforce, if you are able to do so. But there are usually regulation any sport to make it some minimum ride height in the cars. There's always check it that there is no any more crown effect cars. Crown effect car in the motorsport have very much spanned a lot of different series, because it's of course usually meaning the faster the cars go. So usually we have a different settings to the front and left and the ride height. It's depending a lot once again what kind of the car. Usually have to lower the car in the front, because the car maintains a better to the braking power acceleration. But if you can have it, example, to this active suspension, we can lower this acceleration. We usually bring it to the front of the car in the air a little bit higher than the down, and the acceleration, because the car is like the aeroplane wing and upside down. However, the airplane, it's opposite effect. We want to go the down, not the lift. We want to, of course, in this kind of car, we want a downforce, not lift effect. So in this over, we are not aerodynamical, but here is the factors. Factors is the another thing, how much you want a factors to give it the response and the power in. So usually, once again, you just really higher, and the ride height and spring rate. More higher you are, the car also have a better straightforward speed. And then it's just going to the tire pressure and dampers. The dampers, how the tires are, what kind of angle towards the damper angle they have towards the track. It is a lot of different pressure variants, and it's depending what kind of condition, track condition, how the car goes. But it's usually one pretty simple principle. If your tires are very much, if the cars are tracked, you can make it right changes, and otherwise there's negative and positive camper, or just a zero camper. So usually if you want a more to the crit, you get it the negative camper. Because negative camper meaning that the top of this is the inwards and the down is, that meaning it's giving a more crit and more angular to the tires to stick to the towards the track. So that's what we mean, but it have a negative effect, because it means that also the use of the tires, a flat bottom is more in the use, and it's a wear rate. So if there is no tire changes, the positive camper, but in motorsport, in the motor time is the negative camper. The car tires are very usually to maximum because the tires are quite out angular and quite a circular. That means it's giving it really important. Then it's a 2-in. A 2-in is the one of the settings to mean how much the tires in the front or the back are towards of this as straight lines. And if it's 2-in, it will be better control of the race. Tire pressure. Tire pressure is simple as ever, depending a lot what kind of tires you use in a different condition. If you drive one lap, you want a very certain, but there is the most important thing is the tire pressure, how much you create a grit and a wear, and more you have a tire pressure, more it also is a wear rate. Unless you have a tire pressure also lower, but there is also going. So higher tire pressure, the more you have a grit, but also that means that the cars, when the tires are getting heat, and if there is too much tire pressure, it's better to stiff the cars, and they are also looking excessive wear rate and excessive wear rate of the tires. So you will want to be keeping the tire pressure as the balance as possible. Remember always in the first couple laps, and it's dependent of if there is no frequency or pressure and some adjuster. If there is some adjuster, a lot of cars